Okay, good morning. It's been a little while since we recorded one of these, but today's lesson is all about one-dimensional data structures. You should have CT14 open on your screen, and the first question asks us 4 characteristics of a one-dimensional data structure. So whilst I'm talking, can you write each of these down and I'll explain what we mean. So in Python, we talk about lists. In most programming languages, we talk about arrays. They are different, and at A level, we talk about the differences. I'm not going to mention that today because we don't need to know at GCSE. If you're interested, ask me later. So in Python, we use lists, and at GCSE, you can also describe them as arrays. However, an array can only store one data type. In Python, it's possible to have a list of an integer and a string, or mix your data types. You can't do that in an array. An array must only have one data type, as in a list of integers, or a list of strings, or a list of booleans. You shouldn't mix them up. Third characteristic, a single index to access each item if it's a one-dimensional data structure. For example, a shopping list can have item 1, 2, 3, 4, 5. You just have one number and you can see exactly where that value is. You can have two-dimensional data structures. That's not what we're talking about today. A two-dimensional data structure might be like a table where you can say row and column, or a picture where you can say X and Y. But a one-dimensional data structure means one dimension, one index, to find the position within that list. Okay. So when would we use them? We use them when we need to store more than one value, particularly when we want to try and iterate through all of them. It's bad practice to have lots of different variables because you can't use a loop to get through all of them. A list is great because you can have like name square brackets 1, name square brackets 2, or name square brackets I, where I is any value to access the name of any student in the class. Loads better. All right, enough of that waffle. Let's have a look. Knowing what we know now, 12 test scores for one student, I think yes, because you could have scores and then 0, or scores, I don't know, we could have 100 in the first test, 45 in the second test, etc. I'd like you to fill in the rest of the table to think yes or no, and preferably give an example of what that list might look like. So this second one, before I let you work on the rest yourself, is not suitable. You could have a one-dimensional data structure, but you can't have an array. You could have inventory equals, and if you've got to store the ID, like an ID number 44, description chocolate bar, and a cost of £99.99, very expensive chocolate bar. That is a one-dimensional data structure, but it can't be a list. Sorry, it cannot be an array because we've got different data types. We've got an integer, we've got a string, and we've got a float, a real value. So I'm just going to write no, different data types. And we don't need the example if you're writing no. Okay, so let's have a look and see if we agree. The tabard numbers for 2,000 runners in the fun run. Yep, I agree. We could have all the different numbers like this. The records for 2,000 fun runners, number, name, address, no, because we've got different data types in there. Reading data in about beach water testing, key, location, I would say no, because a key might be a number, a location would be a string, we've got different data types. Reading in counts from a file, sorting them and writing them back out, well yes, counts are likely to be integers. We could store all them in one list, one array. 100 random numbers, yeah, absolutely. So how would we do something like this? Well, we could have a two-dimensional data structure, or we could have lots of one-dimensional data structures. Both of those are outside the scope of today's lesson. We won't worry about them today. So, well done. There we go, sorry about that. So for this one, it sounds complicated. Forward traversal and reverse traversal. Traversal just means going through, and forward and reverse just means forwards and backwards. What on earth does that mean? It means we either start looking at the beginning or we start looking at the end. So it says inspect the code and predict what the output should be. Run and test your code until the output is correct. Copy the line of code you added here. So this code doesn't work properly. Let's run it. We've got a bad input on line 18. And we've got some instructions in the same format that you get in a paper 2, maybe in a question 2 or a question 3, where you've got to add some extra stuff. Right, line 16. It says it's a for loop, and we want to go forwards. What does that mean? It means we should start looking at 150. And if we find it, we stop. If we don't find it, we're done. So what are we supposed to be looking at here? If index equals 0, print that. If index is in here, So I'm not entirely sure what the question's asking us to do here. It says a for loop, but if we put a for loop in for index in range the length of in list, I think I know what we're supposed to be doing. Are we supposed to be looking to see if... no. No, still confused. Are we supposed to be doing a linear search here? Really not clear. I think it would make sense if you said what you were trying to search for. So let's say we're trying to search for 376. Then it says, add a for loop. Well, this is set up more for a while loop, because we've got index equals index plus 1. While index is less than the length of in list. They didn't put that extra number in, so what's going on here? They've just made it put the first value and the last value. Seems pointless. But there we go. And then the next one is going backwards. So they told us to do a for loop here, but we've got to be careful with that. If we actually wanted to do a for loop here, for index in range len of in list, this is going to break it. For automatically changes our index. We don't want to do that, because the for loop automatically changes it. If we're going to go backwards, however, for index in range, now at this point, you can remember that we've got a start position, an end position, and a how much we change by. So class chart's positive in a moment. If you can tell me what value should we start at to get to the end of our list, what value should we stop just before to get to the beginning of the list, and what value should we change index by to go backwards. So we've had a really good suggestion of 30 in here, because in this instance there's 30 values. That might be correct in this instance, but it would be better to say, to get your program to count it, in case there was ever another value in there. So yeah, we'd start at the last value. Would we count the values in my list? Well, we could, and it would work in this case, but we want it to work in any program. We want to be able to copy and paste this into any other program later. So actually, we want to use the parameter in list here. So that's the first class chart. So we've left this as 0. I've suggested that that's wrong, and we'll see why in a moment. This one has to be -1 because we want index to change by -1 each time. If we run this, we can see that we've got the first one, but we've never got an index of 0. It never gets to this one. Because remember, in for I in range, or for something in range, we always stop just before we get to this value. So we actually need a -1 in there as well. Just to prove my point, I'm going to put print for I in range 10, print I. Remember, what does range 10 do? It means make something you can iterate through, starting at the first value, and if there's no first value, it's 0. Or it could be anything. I'm going to put 3 in here. We start at that first value, and we go up to, but not including that value. It doesn't include 10. If we were to go backwards, say from 10 to 1, going down by 1 each time, it does not include that 1. So we have to go 1 below what we want. And of course, we can go down by more than 1 if we want. Okay, good, thank you. Activity 4, I think this is much more like a linear search. This time, we've got 2 parameters. Which list are we looking in and what are we looking for? Your job is to traverse through this list, to use a for loop or a while loop, I suppose, to go through each value, to check and see if that value, the thing we're looking for, is in this list at the position that we're currently looking at, index. And if it is, we can break out of the loop. So for example, the first time, we'll look in my list for 636, and our code should find it and tell us it's been found at position 0, 1, 2, whatever it is. So let's have a look at activity 4. It says a traversal looks at every item in turn. That's like a linear search. We can choose whether it starts at the beginning or starts at the end. I'm going to start at the beginning, so a forward traversal. A search only has to keep going until we found what we're looking for, or until we've gone through everything. So add some code to the list, only looping until we found, and it should find these values at certain places. Let's see. I'm just going to pop this on one side so we can see our tests and see if it works. So down at the bottom it says if we're finding 636, we should find it at 21. But it says it's not been found. Now that's wrong. This is a logic error. It's not a syntax error because we don't get any error messages. It's not a runtime error because it doesn't crash. It's a logic error because we get the wrong result. It does what we've told it to do, not what we want it to do. So add the code to search the list, only looping. Right. So it has to be indented because it's part of our procedure. Then we can either use a for loop or a while loop. Let's use a while loop to begin with. While index is less than the length of in list, because we don't want to look past 896, then we want to check and see if we found it. Well, let's see. If the value at index, if in list at index is equal to the thing we're looking for in target, which is our parameter, which is any of these values passed in as an argument, then found is true. Capital T. Will it work? Well, no. Because it goes on forever and ever and ever and ever and ever, because it's always looking at in-list index. Class charts positive question. What is index? Good, yeah, so index is 0, always looking at position 0. So let's increase index. Index plus equals 1. If I can spell index properly. There we go. So there we go. Have we found it? Well, yes, but we've not found it at the right place. It's told us that we found the right ones, but it's kept on looking until the very end. And we don't want to do that. So we've had a couple of different suggestions. We're right to look at line 20 because we say keep repeating as long as the index is small enough, as in we don't want to go too far beyond the end of the list. But not or, we want and. We only want to repeat whilst we haven't gone outside of the list, and found is still currently false. Because we want to stop looking as soon as found goes to true. We're getting closer, but what's wrong now? So now, what we're expecting, index 21, is not the same as what we've got. That's because as soon as we find it, we carry on also increasing the index, and that is a problem. We can't comment it out because then it never increases. So therefore, I'm going to put an else in here. Only if we haven't found it do we increase the index. There we go. That should work. So that's how we can do it with a while loop. Can we do it with a for loop? I'm just going to leave that on there for 10 seconds or so for you to test it, grab it, see if you can make it work. Then I'm going to do it with a for loop. For index in range, well, let's start at 0. Let's go up to the length of in list. Oh, why is it going across quite that much? Oh, because I haven't balanced my brackets. There we go. Then, if, what can we do here? If in list at position index is equal to the thing we're looking for, found is true. Again, we've got the same kind of problem. We're no longer having to manually increase index, so it's not a problem that it's one bigger than we'd expect, but it's still going on to the end. But what we can do is use a break, and that says break out of this for loop. Stop repeating. And that will also work. Out of the two, a while loop and a for loop, I prefer the for loop because you don't have to have the and found equals false. And you also don't have to manually increase index. But just to throw one final solution in, we could also do while index is less than the length of in list. Because break also works to break out of a while loop. However, it's crashed at the moment because we have to remember to manually increase index. So index plus equals 1. What does that mean? It means index equals what index was plus 1. That also works. Notice we don't need to have an else in here because as soon as you break out, it doesn't run that anymore. It breaks out of the while loop. You can choose any of those three. They all work. There's always more than one way to solve a problem. So when you've done all, if you can, make sure you've got your screenshots in, save your Word document, close your Word document, and it gets submitted to Half Term 9 Algorithms and Programming, please. Any remaining time, we're going to be focusing on Compete with Code.uk challenges for this week. Thanks for your hard work.